Hello, fourth graders. Today for our math lesson, I'm actually going to start with a little story, real life story here. I was talking to my mom and dad on the phone, and my mom and dad have a front yard, front of their house, that is 8 meters long and 7 meters wide. And they're building a deck in that yard that's going to be 6 meters long and 5 meters wide. Now, in the space that's not covered by the deck, they're planning on planting grass. So they're trying to figure out what is the area of the space that's not covered by the deck, so they know how much grass to plant. Take a look at the figure that's on the slide here. That's illustrating what they're trying to work out at home. Now, anytime we solve math problems involving area, these are real world skills that we are using. And in fact, the problem with my parents' deck in their front yard, this is a real world problem that they have to solve using their measurement skills related to area. And I'm going to show you how we can go about doing that. So let's go back to the diagram showing my parents' front yard and the deck that they're planning on building there. Okay, and our job is to find what is the area of the space not covered by the deck. So that green space, think of it as the area of the grass pathway. You'll hear me using that word quite a bit, the pathway around the deck. We're going to approach this just like we have approached solving area problems for other composite figures. And in fact, this is a type of composite figure. Okay, but instead of the rectangles being side by side or one on top of the other or next to the other, these are actually overlapping rectangles. Okay, that deck is built right on top of the yard area. So I actually have two separate rectangles that are here. Okay, yeah, I could put them side by side and that would make a type of composite figure. But this is a special type of composite figure where one is on top of the other. Okay, so as with any other kind of composite figure, our very first job is to separate out the rectangles. And then we're going to find the area of each rectangle. This is just like what we've been doing. So we'll find the area of each. So I'm going to go ahead and do that right now. So my yard area, which is represented by the green rectangle, okay, so that's going to be my parents' yard. We have 8 meters. Let's go ahead and type that in. 8 meters multiplied by 7 meters, because remember, length multiplied by width is going to give us our area. So that's going to be the area of the yard space. So 8 multiplied by 7 is 56 square meters. This is area, so we're talking square meters is going to be the area of our green rectangle, the yard area. Okay, we're going to go over to the deck now, and we're going to find the area of the deck. Again, length multiplied by width. All right, length 6 meters multiplied by a width of 5 meters. 6 multiplied by 5 is going to give me the area of the deck. Okay, so 6 times 5 is 30. 30 square meters. I know this is going right on top of that word deck, and that's going to be the area of our deck. Okay, so we found that. That's something that we're used to finding. Okay, finding the area of the separate rectangles there. There we go. But the last step, in order to find the area that was not covered by the deck, okay, remembering that these are overlapping originally, we are going to subtract. So here's the difference with today's lesson. In order to find the area of the pathway, we need to subtract the smaller area, the area of the smaller rectangle, from the larger area. Okay, so that means that I need to go ahead and say, okay, my larger area, 56, okay, meters squared, minus 30 meters squared is going to equal the area of the pathway. okay? Because we're subtracting out the space that would be covered by the deck. So 56 minus 30 would give us 26 square meters, and that would be the area not covered by the deck, okay? Again, remembering that, I'm going to go back and layer this over again, remembering that the deck was right on top of the yard area. So whenever we have to find a pathway like this, the key is to subtract. So in today's math lesson, we will be practicing finding the area of a composite figure when you have overlapping rectangles. And you need to find the area of a specific part, or again, think of it like path of the figure. To find the area of a specific path, you subtract the area of the smaller rectangle from the area of the larger rectangle. I recommend that right now, if you do not have pencil and paper or a marker and dry erase board in front of you, you need to pause this video and go get that. We're going to be drawing some rectangles and you're going to be practicing finding the area. It's not enough just to watch this video. You need to practice doing this along with me. Okay, so pause this video, go get those resources, and I'll see you back in a moment. All right, and my friends, we're going to continue on. We're going to do 4 more examples of finding the area of either a pathway or a specific part of a composite figure. Okay, so take a look at this figure that I have here with the pink and white rectangles. Our task is to find the area, okay, the area of the shaded part of the figure. Okay, important. I'm finding the area of the pink part of the figure, not the white part. That's what I want to find. Okay. Now, when we take a look at this, don't think of this as puzzle pieces put together. I really encourage you to think of these as overlapping shapes, okay? Because you're always going to want to start by, in your head or even just on paper, decomposing this composite figure into its overlapping shapes, okay? So go ahead and sketch this out for yourself. And again, if you need to pause the video in order to sketch it, please do that. So my first step is to decompose this into its rectangles. I have 2 rectangles, one that's in the background, that's pink, and one that is in the foreground, that is white. Okay, and what I mean by that, again, overlapping, I'm going to actually take this white one off, including its measurements. Look at how it's labeled with the measurements. I'll put it back to where it was originally. All right, I'm noticing that along the top, that horizontal side, I have a 5 centimeters right next to a 4 centimeters. And then vertically, I have a 3 centimeters and a 2 centimeters. Those, the 4 and the 3, those apply to both the pink rectangle and the white one that was on top of it. Now our task, remember I said that we start by actually finding the area of both of these rectangles before we do any other work, any subtraction. So I have to find the area of my pink rectangle and I have to find the area of my white rectangle. Okay, let's do the white one first because I don't know about you, but it looks to me to be the easier one to do first. Now remembering area equals length multiplied by width, that is our formula. Okay, so my length and width, so area equals, I have a length of 4 centimeters multiplied by a width of 3 centimeters. So the area of that white smaller rectangle is going to be 4 multiplied by 3 is 12 square centimeters. Okay, so that's going to be 12. And then for my pink one, now before I find the area, I actually have to do some combining of sides because notice, let me switch over to my pen tool. Notice that for the length, this would be the length, the longer side, I actually need to combine together the 5 centimeters and the 4 centimeters. So 5 plus 4, well, 5 plus 4 is 9. So there's my length. And then my width would be the sum of the 3 centimeters plus the 2 centimeters. 3 plus 2, those two parts together equal 5 centimeters. Okay, so in order to find the area of this rectangle, again, area equals length multiplied by width. My area would be, okay, a length of 9 centimeters multiplied by a width of 5 centimeters. 9 multiplied by 5 is going to give me an area of, if you said 45 square centimeters, you are correct. So I have my pink rectangle that is 45 square centimeters, and I have my white rectangle that is 12 square centimeters. Now, remember, this white rectangle was right on top here. So it's almost like in order to find the shaded part, so that pink part that is revealed when I have the overlapping figures, I have to imagine like I'm taking a chunk out of it. Okay, so I am taking 12 square centimeters out of the 45 square centimeters. So then in order to find that final area of the rest of this revealed shaded part, I'm going to say 45 centimeters squared minus, there's that little 2 for squared, minus the 12 centimeters squared from the white rectangle. That's the little bite that I'm taking out of it. I am taking out 12 square centimeters. Okay, 45 minus 12 is going to give me 33 centimeters squared. Okay, so the area of the shaded part is going to be 33 square centimeters. We decompose, we find the area of the two rectangles, and then we subtract the smaller amount from the larger amount. Let's go ahead and try another one. This one is very similar. This next example is very similar. Okay, this time though, the white rectangle that's on top, I always imagine the smaller one as being on top. That one, now it's centered instead of being in the corner. Okay, and the way that we have the numbers labeled, the measurements is a little bit different as well. All right, so just take a look at what we have. Examine the information that we're given, because we use whatever we know to help us find what we don't know. Okay, I see two rectangles. All right, the way that I see it is because I imagine there is a smaller rectangle on top of a larger rectangle. All right, these are all square corners, so these are 90-degree angles. So if I have an outside shape that has 4 90-degree angles, I know it's a rectangle. Okay, we have to find the area of the shaded part of the figure. So we're going to find the area of that revealed purple part of the figure. To do that though, I'm going to start by decomposing this into its rectangular parts. So there are going to be 2 rectangular parts. Okay, I have my white rectangle and I have my purple rectangle in the background. All right, as I move that white rectangle off the top of the purple one, you should know that something super important is missing off of that. All right, I have only one measurement on there. This is a rectangle, it is not a square. So I need another measurement. I have a length, I have 4 yards as my length. I do not have a width. Let me put it back. Do I have any information on here that would tell me the width of that rectangle? And if you said, yes, indeed, I do have that information, you'd be correct, because look over on the left side of the purple rectangle. I have this measurement that shows, it's got the little arrow that's showing from the top corner halfway down that side is 3 yards. It happens to match up perfectly with my white rectangle. Okay, so I actually do have a measurement for the width of that white rectangle. It's just that that measurement, I had to find it in a different spot. I had to find it on the outside of the background rectangle. Okay, so that was there already. So I'm going to go ahead and move out my white rectangle over here. I know that its width, based on the information that was given to me on the purple rectangle, I know that its width is 3 yards. Okay, so I can go ahead and I can find now my area of the white rectangle. The area of the white rectangle is going to be found by multiplying my length, 4 yards, by the width, 3 yards. So 4 multiplied by 3 gives us 12. Whoops, that's a plus sign. Gives us 12 square yards. Okay. So we've got the white rectangle. Now we have to go to the larger purple rectangle. Now, just like in the last example, you should notice that we have to do some combining of measurements. So if you look at the length, I need to have a length and a width. If you look at the length, the long sides here, I actually need to combine these 3 parts, the 2 yards, the 4 yards, and the 2 yards to find the total length. So 2 plus 4 plus 2, 2 plus 4 is 6, plus another 2 is 8. So I have a length of 8 yards. So both of these long sides would be 8 yards. And my width, now notice I do have measurements on both sides, both widths of this rectangle. But I want to use the larger one because this is the measurement, if you notice the arrows, this is the measurement of the entire vertical side. So I'm going to go ahead and find my area of the larger rectangle. Okay, so that area is going to equal a length of 8 yards multiplied by a width of 6 yards. So 8 multiplied by 6 is going to be 48 square yards. So now I have the area of both of these rectangles. I need to go to my final step. Now, if this were a composite figure where the rectangles were side by side, remember I'd be adding together the areas, but that's not the case here. We're talking about rectangles that are overlapping. They're on top of each other. So I'm going to go ahead and just copy this for ease here. So I need to, instead of adding, I need to subtract. I need to take away that chunk that is where the white rectangle is. Okay, so I'm going to go ahead now and I am going to subtract. I'm going to take my larger area from my larger rectangle, which is 48 square yards, minus my smaller area from my smaller rectangle. That chunk taken out is going to be 12 yards squared. So 48 minus 12 is going to give us the area of the shaded part, that revealed shaded part, that kind of pathway around the outside of the figure. So 48 minus 12 is going to be 36 square yards. How are we doing here? I hope we're hanging in there. Okay, we're going to look at 2 more examples that are going to look a little bit different, and you're going to get some different types of measurements labeled on there. So let's take a look at these. Now, also on these last 2 problems, I am not going to be separating out the overlapping rectangles, because here's the thing. When you're doing your own work at home, you don't have these rectangular pieces that you can separate out. You either have to draw it yourself or you just have to visualize it. Rectangle 1, rectangle 2, okay? Let's look at this problem and so you can see what I mean. Miss Hall is putting a carpet in a rectangular room. Anytime we have a reference to a shape, we should pay attention to that. The border around the carpet is 1 meter wide. Okay, so we have a border. So the border would be that orange edge space. Notice the yellow carpet is labeled in the middle. So the border would be this edge space, okay? We know that that border is 1 meter wide all the way around. Okay, so that means from here to here is 1 meter. Okay, from here to here is a meter. From here to here is 1 meter. You get the point? All the way around is 1 meter. Okay, I could go through and label all the way around. These are 1, 1, 1, okay, 1 meter all the way around. We have to find how much space is not, important, underlined, is not covered by the carpet. So I'm finding the orange space, that orange pathway around the edge of the carpet. Okay, so we need to follow our usual procedures. Start by decomposing this into its separate rectangles, find the area of each, and then we'll subtract, okay? So I have the carpet and the floor. So I'm going to go ahead and I will write out, I've got the floor, okay, that's the orange. I'm going to have to find the area of the floor. And then I also have that yellow carpet. So I will go ahead and find the carpet as well. So look at the measurements that we actually have labeled. Okay, I only have numbers, measurements labeled for the floor. If you look on the outside, I've got 8 meters. My floor is 8 meters wide by 14 meters long. Okay, so I'm going to go ahead and find that area since I know I have those measurements. So 14 meters multiplied by 8 meters. That's going to be my area of the floor. Take a moment, pause your video. I want you to find the product of 14 multiplied by 8. Okay, I hope you have stacked it up and found that measurement. So our area of the floor, 14 multiplied by 8, is 112 meters squared. Okay, so that's the area of the floor. Next, we need to find the area of the carpet, but there's no measurements labeled on the carpet. So what do I know? I know in the problem that I was told that that there was a 1 meter border going all the way around. So that means that the length of the carpet, okay, the length is going to be 1 meter shorter on the right and 1 meter shorter on the left. And the width is also going to be 1 meter shorter on the top and 1 meter shorter on the bottom. So I need to subtract out from the floor measurements the border. Okay, so let's start with the length. Now I know the floor has a length of 14 meters. If the carpet is 1 meter shorter on the left side and another meter shorter on the right side, that's 2 meters, one on each side. So I'm going to subtract 14 minus 1 on the left, minus 1 on the right. So that's going to be 14 minus 1 is 13, minus another one is 12. So this carpet has a length of 12 meters. Let's go to its width, the shorter side. Same thing, I've got 1 meter on the top and 1 meter on the bottom of border space. So if the width of the floor is 8 meters, I'm going to subtract 1 meter from the top here and another meter from the bottom. So 8 minus 1 is 7, minus another 1 is 6. So my carpet now has a length of 12 meters and a width of 6 meters. So 12 meters multiplied by 6 meters, and that will be the area of my carpet. So pause this video, stack up 12 and 6, multiply. All right, I hope you're back again. 12 multiplied by 6 is going to give me 72 meters squared. So that's the area of the carpet. All right, so we found the area of the rectangular floor. We found the area of the rectangular carpet. Last step, we are going to subtract, because that carpet is covering up part of the area on the floor, we are going to subtract the area of the carpet from the area of the floor. So we're taking the smaller area and subtracting it from the larger area. So that means I'm going to do 112 meters squared minus 72 meters squared. Okay, so 2 minus 2 is 0. Okay, and 11 minus 7 is going to be 4. So how much space is not covered by the carpet? That's what we were finding. Okay, how much space is not covered by the carpet? 40 meters squared are not covered by the carpet. Okay, and there's the answer to our problem. We're going to try one last problem together. Okay, reminder, our steps, we decompose into separate rectangles, we find the area of each rectangle, and then we subtract. This problem is similar to the carpet problem that we just solved. We are finding the area of the pathway around the field. So just take in what's in this diagram. All right, I have a green field, rectangular green field in the middle. And then behind it, again, I imagine overlapping rectangles. Behind it, I have a white rectangle that maybe is the stadium, okay? And I see that there is a pathway around the field. So that's what I'm going to find, okay? So I have my stadium rectangle, if that makes sense, the outside edge of the stadium, and then I have my field rectangle in green. I have a lot of measurements labeled on here, so I'm going to use those measurements to help me. And these actually are super helpful measurements. You just have to make sure you're really paying attention to them. Okay, and what I mean by that is check out on my vertical side, I have 2 meters for that little bit there, 12 meters, 2 meters. Then horizontally, I have 2 meters, 25 meters, and 2 meters. See the little tiny lines there? So I can imagine, I'm just going to go ahead and kind of connect that and connect that. Kind of go like this so I can extend it. So what it appears, since I have, these are both rectangles, it appears that all the way around I have a 2 meter pathway. Okay, so all the way around it's 2 meters. Look at the 25 meters that's horizontally down below here. Okay, this 25 meters matches up this arrow here matches up perfectly with my field. So the length of my field. So this 25 meters, that's the length of my field. Let's go vertically and look at width. Okay, so I've got this 2 meters kind of marking the edge where the border is, the pathway, and 2 meters there. But this 12 meters, where those arrows are there, that matches up perfectly with our width of the field. So the width of our field is 12 meters. Okay. So I have my field. I'm going to go ahead right over here. I'm going to write out my formula to find the area of the field here. So area equals length multiplied by width. So I have 25 meters multiplied by 12 meters. Sorry, that's getting a little messy there. So 25 multiplied by 12, stack them up. You have to do a little bit of work here. So the area of the field itself is going to be, I hope you found 300 meters squared, or squared meters. Okay. Now we have to switch over. We're going to switch to the kind of that stadium outside. I'm referring to it as the stadium. I'll switch to blue here. Okay, so that outside rectangle, the stadium. Notice that we do need to do some combining of those smaller measurements. Okay, because those smaller measurements, these all go together for the length and width. Okay, so all of these need to go together. So for the length, I have 2 plus 25 plus 2. So 25 plus 2 is 27, plus another 2 is 29 meters. So we have 29 meters for the length. And my width, I have 2, 12, and 2. So 12 plus 2 is 14, plus another 2 is going to be 16, a total of 16 meters. So to find the area of the stadium, I have to multiply 29 meters by 16 meters. Pause this video, stack up 29 and 16, and please do the multiplication. You'll check your answer when you get right back on. All right, I hope you did that work. 29 multiplied by 16 will give you a total area of 464 for the entire stadium floor, 464 meters squared. Now, go back to the original problem because we're not done yet. The original problem says, what is the area of the pathway around the field? Okay, so to find the area of the pathway, sometimes it's the shaded part. In this case, it's not the shaded part, it's the area of the pathway. To find the area of the pathway, I'm going to subtract the smaller area, the area of the smaller rectangle from the larger rectangle. So that means I'm going to subtract 464 meters squared, minus 300 meters squared. So 464 minus 300 is going to give you 164 square meters as the area of the pathway around the field. Boys and girls, I know there's lots of steps involved in these types of problems. We will be practicing these problems throughout the week. I encourage you to just work step by step, work very methodically and carefully, and pay attention to all of the details. Thank you so much, my friends.